Anyway, so I've got Insight open, and like before we go, run Insight, and as per usual it takes a while to start up, but when we're getting into Insight we follow that same process of before of importing data and then using Insight to analyse it. So a little bit like with inference, all of the legwork is done for you, so it's more about you interpreting what you're doing. So while today I'm going to go through how to use Insight, after this it's going to be more about analysing what you see. So first of all we'll import our data, and so I've got a data set ready on my desktop, and this is following the temperatures of different places in the world. And with Insight, its date column has to be organised in a particular manner, but the files that we give you should usually be already formatted into that format that it wants. Okay. Now to do time series, you have to go along to advanced. Depending on what platform you're using, George, can you put your screen down? Depending on what platform you're using, advanced may be a button down here. Okay. So we click on advanced and we go time series. And then it asks us to select the time variable. So we're going to select date as the time variable, alright, which makes sense. And usually you'll have some heading like that that describes your date variable. And then we choose the time series data that we want. So we've got all of these different places in the world with their average monthly maximum temperatures and their average monthly minimum temperatures. So let's find one that we're probably more interested in. Auckland. Okay, so there's Auckland, and when we click on time series plot, that just gives us a time series graph showing this data over the period of time that we've got. Okay, now that red line is what we call a moving mean or a moving average, and so what it does is it works out the average temperature for the whole year and plots it. Are there any ideas of what the point of having that red line is? Sort of. No, it's... Yeah, what Hayden said, so you can see what years are warmer than... What Patrick said. What years are warmer than others. Okay? Sorry. So, what things do we immediately notice about these graphs? What's an obvious thing that we notice? Seasonal. Okay, so in the winter, our average minimum is much lower. Our average maximum is much lower than in the summer. Okay, so that red line is just taking away the effect of the seasons, and like Patrick said, it's illustrating whether one year is warmer than another. So if we track along, we can see it's relatively even, but just after 2004 it dips a little bit, and then at around 2005 it's a little bit higher. So it does undulate a little bit depending on wider climatic reasons, but that's giving us a better idea of what's happening year to year as opposed to what's happening in individual months.
So after 2004 that high then?
Yep.
You're saying that like 20 was the high?
Average maximum throughout a year. Yep, which is relatively high because, yeah, and I mean it's also interesting to note that like we've got some winters where the average maximum is lower than other winters, and some winters where the average maximum is quite high. So there's things like that that you can notice and comment on as well. Okay, with a bit of research you might be able to find out some things like what years had an El Nino climate effect, what years had a La Nina climate effect, and how that might affect those things. Alright, so if we, just focusing guys, that's just one aspect of what we have to do in Insight. Another thing that we can look at is seasonal effects. So if I click on that, that gives me this graph here. So what it's done is it's calculated what the seasons look like for each year and how different they are from the average. Alright, so we have each individual year's seasonal effects by each month, and then this graph on the right is the average seasonal effects. Alright, so it's taken all of those seasons, averaged them out, and this is the difference from the mean yearly temperature. Alright, so according to this graph, which month is the warmest in Auckland for a maximum? February. Okay, then January is the next warmest, and then March, and then December, and April, November, and so on. Okay, so with the coolest month being July. Yep. Okay, so that's another graph that we need to get from Insight. And then we have this other button down here called Predict. So I can click on Predict, and it gives us this raw data here, which is showing us what the average in this column. Whoops. I'll try that again. Connor, you realise I'm recording this?
What?
I'm recording this video, so please. Alright, so we've got month by month prediction for the coming years. Now, since this data only goes up to 2012, it's predicting from 2012 through to October 2014. And in the column on the left-hand side, that's its prediction. And then we've got the lower 95% bound. So, if you like, the confidence interval of where the lower bound would be for the prediction, and the confidence interval for the upper bound. Alright? So on the graph, that's what that red shaded area is representing. So the solid red line is representing our average sort of prediction, and then the red shaded area is presenting our 95% confidence interval. So in other words, we would be 95% confident that the average monthly maximum would fall somewhere within that shaded range. Alright? Okay, so that whole process of getting a graph with a moving average, a graph with a average seasonal effect, like this one here, and then a graph with our predictions, like this one, that's sort of your basic nuts and bolts that you require before you start your discussion, okay, whether your discussion is at achievement or excellence level. Alright, so regardless of all that, you're going to need this bit, okay. Now when it gets to an excellence level, what you're looking at is creating your own variable out of the variables that you've been given. So I'm just going to have a look at the data set that we were given, and here we've got a whole lot of different towns around the world with their average maximum and their average minimum. Okay, so we're looking at Auckland average maximum and Auckland average minimum. So what we want to do is see if we can create another variable altogether. So let's just get rid of everything that's distracting us from Auckland at the moment, because we're just focusing on Auckland. Okay, so just focusing on Auckland, we've been given the maximum daily average and we've been given the average daily minimum. How could we create another variable out of these? The difference. Okay, so we'll try the Auckland difference. Does anyone know what the technical word for the daily difference in temperature is? Range is part of it. Difficult. Range is part of it. It's called diurnal range. Alright, urnal is like daily, so diurnal range is saying the range between the maximum and minimum on any day. Alright, so we'll just make this the maximum minus the minimum, and we'll populate that down, just check that it goes all the way. Okay, and I'll save this as another file. So save this on our desktop so it's easy to get to, and we'll call it Temp World 2. I'm recording, but your voices will be in here. Okay, so I'm going to go back to Insight and import my new data, which is Temp World 2. And because we're still doing time series, we need to go back to the Advanced tab, Connor, and click on time series. Our time variable is still date. This time I'm going to do Auckland difference. And so I'll do a time series plot first up. Okay. Alright, so just looking at this graph, we've got something quite different to what we had before. Before we had a really clear seasonal effect. Do we have a clear seasonal effect here? No. Okay.
Oh, yeah. Alright.
It's definitely like ups and downs.
Yep.
It's not like
It's not consistent.
It's probably less than
Okay, so there's lots of discussion that we can generate around there. But the point is that by making another variable to look at, we've found something interesting to talk about at an excellence level for this assessment. Okay, we'll go through the same graphs as we did before again. So we will find our time series. Okay. Alright, we'll look at our seasonal effects. So here's our seasonal effects. And although our seasonal effects seem kind of random when we look at that left graph, when we look at our average, can we see some kind of seasonal effect with our average? Yeah. So in the months of January through to about April, what's the...
There's more difference in the temperatures.
Good. There's more difference in the maximum and the minimum. Whereas in winter, there's less difference between the maximum and the medium, maximum and the minimum. Okay. Because if we look at the graph, the graph shows us 0. So 0 is where your daily maximum and your daily minimum is the same. Okay? No, that's not quite true. It's not where it's the same.
yeah, it's like
That's where, yeah, that's the average. Yeah. So guys, I still want you to pay attention here, Rory and Caitlin. So this 0 represents the average daily difference. Alright? In summer, we have above average daily difference, and in winter we have below average daily difference. So whenever it's doing your estimated seasonal effects, the 0 mark is always representing your average seasonal effect. Okay? Alright, let's look at our other graphs. We'll look at predict. And here's our predict graph. And while we have a pretty constant looking solid red line, because of the massive amount of variability, what's happened to our shaded area?
much bigger outline.
Yep, so because our confidence interval has to be 95%, we have a much bigger area for this than we did for when we were looking at our daily average maximum. Okay, so that's just a short example of what we can do with insight to get us started on our assessment.